everyone, welcome back to Learn Math with Jessie. Today we're going to cover how to solve logarithmic equations using identities. You can refer to my videos in my short section to learn about those. So first things first, let's just expand this difference of squares. So the x squared minus 4 can become x minus 2 times x plus 2. And then we use the power rule to bring that 2 to the exponent of the x plus 2. Now we use the quotient rule, right? Because we have a subtraction between these two logs with the same base, to put one over the other. And then we see that these two terms cancel out. So we're just left with log base 2 of x minus 2 over x plus 2 is equal to negative 2. Now let's convert this into exponential form and we obtain this equation. And now we can convert the 2 to the power of x, 2 to the negative 2 becomes a quarter. And then we use cross multiplication and we obtain the following equation. Now we bring all the x's to one side and all the constant values to the other, and we get that x is equal to 10 over 3. Now just a reminder to always check the domain because log of 0 and log of negative numbers do not exist. So if we plug this 10 over 3 back into the x squared minus 4, we see that we still get a positive value, right? So this is no concern here. So it works and it's our solution. For this next problem, I'm just starting off by bringing that 3 as the exponent for the 2. So that's the power rule. Next, I'm going to use the quotient rule to put that ln 2 to the power of 3, which is 8, as a numerator and x as the denominator. Next, what I'm doing is I'm using the one-to-one property of lns and logarithms to say if we have lns on both sides with the same base, we can equate the values. So we get that x minus 2 is equal to 8 over x. Now I'm just cross-multiplying, so I get x times x minus 2 is equal to 8. Bring everything to one side, and then we can use sum product, so I'm just speeding that up here. Then what we end up getting is x minus 4 times x plus 2 is equal to 0. So we have that x is equal to 2 or x is equal to negative 2. So now we have to test the domain. So if we plug in the negative 2, we see that we get ln minus 2, which is negative 4, which doesn't exist, right? Whereas when we plug in this x is equal to 4, we get ln 2 and we get ln 4, which works. For this last problem, I'm starting by bringing all logs to one side. So I'm subtracting from the right side log 2 of x plus 3. Now what I'm doing is I'm using the quotient rule and the power rule, so I'm putting that 2 as the power of x, and I'm putting that x plus 3 in the denominator. Now I'm doing 2 to the power of 2 is equal to x squared over x plus 3, cross multiplying, and then once expanding, we get x squared minus 4x minus 12 is equal to 0. Now I'm speeding this up. Right here, we're simply doing sum product, and when we do that, we obtain x minus 6 times x plus 2. So x is equal to negative 2 or x is equal to 6. Now, if we plug in negative 2, we see that we get log of negative 2, which doesn't exist. So naturally, x equals 6 is going to work, and it's going to work with our domain because we're just going to get positive values. Thank you so much for tuning into this video and for learning how to solve log equations using log properties that I described in the playlist that can be found on my channel. See you in the next one.